In the last lecture, we have started with the topic lines of regression, and we know how the regression analysis help us to understand the relation between the attributes of the data given, and then how we are able to compute, or up to what level we are able to compute. Okay, so let us try some more examples based on the linear regression. So let's have the another example. So here we have to find the line of regression of y on x, and then we have given the following data. So using this data, we have to find the line of regression, and after finding the line of regression, we have to find the value of y at x is equal to 15.5. So we need to know what happens here at x is equal to 15.5. Okay, so let us try the solution. Okay, so we can have, okay, so what we'll write is, we can write that the line of regression of y on x be given as. So what we are having here, see, we have, this is y on x, so y minus y bar is equal to byx, and here we have x minus x bar. So let this equation 1, where we have this byx is equal to, what is that? Summation xi minus x bar yi minus y bar, and upon summation xi minus x bar bracket square. So this is 2 is the coefficient of regression is the coefficient of regression of y. Okay, so that's what we have. Now we know what we have to do is we have to calculate these terms. So what we have here, and we have x bar is equal to summation xi upon n. Then y bar is equal to summation yi upon n, where n is the number of observations. So what we know here, what is the value of n here? How many observations are there? How many observations are there here? I hope you're writing with me. Yeah. Okay. So good. Correct. So there are 7 observations. So the value of n is 7 here. Okay, that's great. Okay. So here n is equal to 7. Okay. So once we know n is equal to 7, then first task is to find out x bar. And once we are able to get x bar, then we have to find out these terms. Okay. So we know how to make the table for this. Okay. So what we have is then consider the following. Okay. So we have to get the table here, and you know how to calculate the table. So what are the terms required in the table? So what we have here, we have given x, given y, then we have xi minus x bar, then we have yi minus y bar, then we have product of this xi minus x bar into yi minus y bar. And here I need xi minus x bar bracket square. If we want to find out both the lines, then we have to go for the term yi minus y bar bracket square also. Okay, so this is what the table we have to consider. So we are interested in summation of these columns. Okay, so here we have to write x observations. Here we have to write y observations, and then give me what this sum is. Summation x, summation y, and then after that we'll need these summations. I hope you are calculating with me. And this table only we have to first calculate uh, x bar. Okay, so what we have to do is we can say um, the above table we have x bar is equal to summation xi upon n. So we know the value of n is 7 here, and y bar is equal to summation yi upon n. We know the value of n is 7. So what do you got? What is the value of summation x and summation y? I hope you are making the table. I want you to get the value of summation x and summation y. So what you got? Summation x 113 and 191. Okay. So 113 and 191. Yeah, that's good. Okay. So you got the summation. So this is 113 and 191. So you got here 113 and 191. So what is the value of x bar and y bar you got? Value of x bar, what do you got x bar equal to? Yeah, 16.14 and 27.28. Okay. Okay. So that's good. You got the value. Okay. So we can consider this as so we got this 16.24 and this is 27.28. Okay, and now calculate these tables. Okay, so these columns you have to calculate first, and then these columns you have to calculate. So now we are interested in these values. Okay, so these are the values we need to calculate finally. So I want you to calculate these values. So calculate these values, and then we'll find out what is the coefficient of regression, and then we are able to calculate the line of regression. I want you to calculate this table. So please calculate the table. I hope you are calculating with me. Okay, and you are getting the value also. So, how many of you have got the value? Are you getting the value? So, please check your table with mine one. Okay, so I hope you have got the value. Okay, so we don't want the summation xi minus x bar. We are interested in the product and the next columns. So check your table with this. This should be the values that you are getting. So how many of you got these values? Okay, so what we have here, we are not interested. See, we are not interested in these values. Okay, so we don't need this. This is your x. This is y. This is xi minus x bar. This is yi minus y bar. This is xi minus x bar into yi minus y bar. What do you have? Xi minus x bar bracket square. And this is yi minus y bar bracket square. So for this example, what we are interested in these two values only. Okay, this is the extra that I have calculated. So if we want to find the line of regression of x on y, then this table is useful. Okay, so now you can see how many of you got these values. Okay, so how many of you got these values? Okay, so that's good. Some of you got these values. Okay, good. Okay, so now let us have these calculations. Yes, you got the correct ones. Okay, so once you got these values, then we are able to calculate the coefficient of regression. So this is the coefficient of regression that we have to calculate first. And hence, what we get here. So this I have used as it is going to be 142, and this is 57. Okay. So now what we can write is from equation 2. Okay, we have first we want to calculate what is byx, and then only we are able to calculate the line of regression. Okay, so what you have here, byx is equal to, okay, summation. You have xi minus x bar, yi minus y bar upon summation xi minus x bar bracket square. So these values you can have from the table. You can see this is going to be 192 and this is 158. So we can write here. So it is 192.7143. I have considered the 4-digit accuracy. So 158.8571. Now give me this value. What value you are getting this? So give me the value of byx. What is the value of byx you are getting? How many of you got the value of byx? So it is 1.2127, 1.2131. Same calculation, you should not get the different values. Yeah, because the calculation already I have given you. So 2131. Okay. So you got the value. This is going to be, this is what you have here. So it is 1.2131. Okay. And means we get here. So we have byx is equal to 1.2131. Okay. This is the coefficient of regression. So is the coefficient of regression. Okay, so that's what we have. And now what we can write is we can write from equation 1 we have. Okay, so once you know what is byx, then only we are able to know what is the line of regression. So what we have here, this is y minus 26 point. We have here 27.2857 is equal to byx 1.2131, and here x minus x bar, so 16.142. Okay, so here we have put all these values that we have calculated. Okay, and once we put this value, now it remains simplified. Okay, so simplify this. Y minus 27.2857 is equal to 1.2131 x minus, so this is 1.2131 into 16.142, and this yeah. So now you can have this constant on the other hand side. So you can write y is equal to 1.2131x minus 1.2131 into 16.142. Then this will be plus 27.2857. So then we can say the line of regression of y on x is, so what we get here, the line of regression y is equal to 1.2131 x. Then give me this constant what you are able to get. So what is the value of this constant, whether it is plus or minus? So that you have to give me. Please give me the constant if you have calculated. Calculate this constant and tell me what is the value that you are getting with the sign plus or minus. It is you should not have two different values. Partial, you have to be careful. This minus one is minus. So you got this to be 7.7028 or 38. In 39. So we accept this 38 is good. Okay. So we can have this is to be 7.7038. So you got this plus 7.7038. So this is the line of regression that we have obtained. So now see the question. What was the question given to you? You have given to find the line of regression of y on x, and then once you get the line of regression of y on x, we have to calculate the value of y at this point. So we have to calculate what happens at this point. So we have to find what will be the response of y when x is 15.5. So we have to write here at x is equal to 15.5. We have, so what will be y? Y will be 1.2131 into 15.5 plus 7.7038. So give me what is the value of y you will be getting. So what is the value of y you got? 26.5068. Okay, that's good. Yeah, so we got the value of y to be 26.5068. Okay, so that's how you are able to get the value. Okay, so that's great. Yeah, here we got this value. So this way we are able to get the value of y using this line of regression at the particular point. Okay. So do you have any doubt in this example? Do you have any doubt in this example? Okay, that's great. Good. So let us try to solve the another problem. Okay. So now what we have to do is we need to understand what is the relation between the R and this coefficient of regression and coefficient of correlation. So in the starting only I have given you the formulae. Okay. So what are the formulas for? Okay. So I have given you the formulae for the relation between the coefficient of correlation and the regression coefficients. Okay. So what we know is we have Byx is equal to, so it is R into sigma y upon sigma x, and Bxy is equal to R into sigma x sigma y. Okay, so using this we have to consider. Okay, so then what we have is, if I take the product of this, I'll be having R square is equal to Byx into Bxy. And hence what we get here, take the square root. Okay, so if I take the square root of this, so R will be square root of Bxy into Byx. So we have, this is Bxy into Byx. So you can have this is possible only if. Okay, so when this will be possible, see that we have seen the coefficient of regression. So we got this value to be positive. Okay, we also have solved the previous problem and we got the values to be positive. So R is the square root of this. So that means R square has to be positive. So when this will be positive, if this Byx is positive and Bxy is positive, and also a possibility that Byx is negative and Bxy is also negative. So that means these two coefficients Byx and Bxy will be either both will be positive or both will be negative. So you cannot have one positive and one negative, because if it happens that one positive and one negative, then R square does not exist. But it's not possible for any data. R always exists for any data. Yeah, there is no such data where R does not exist. So R always exists, and that means this two will be either positive or this two will be either negative. Okay, because we know these are always positive. So this term is always positive. So if this is negative, R will be negative. If this is positive, R will be positive. And hence, the important observation that we have to notice is the signs of Pxy, Pyx, and R are always same. Okay, so what it means? That is, if R is negative, then Pyx and Pxy are also negative. Okay, and moreover, if R is positive, R is positive, then Pyx and Pxy are positive. So this triad R, Bxy and Byx will always follow the same sign. So this is very important that will help us to understand the signs of R, Bxy and Byx. And we know Byx and Bxy will always have the same sign. Okay. So R is also included in them. So this triad will have always the same sign. Okay. So third you can say Pxy and Pyx have always same sign. Okay. So this pair will also have always same sign. This triad will also have always same sign. So if one is negative, definitely the other is negative. If one is positive, definitely other is also going to be positive. So these are the remarks which will help us in solving another set of problem. Okay, so we try the another type of problem now. Okay. So here we have uh, what is the question here? We have find the lines of equations of lines of regression. So when it is said that lines of regression, that means we have to find out both. Okay, for the following data. Also, we have to find what is the value of R, and then we have to estimate what happens if Y is going to be when X we have 15. So here you can say X will be here somewhere. So this is the predictive model. Okay. So you can see the previous model we have seen. What was the previous model? We have to find the value of X, Y. See, we have to find the value of Y when we have X is equal to 15.5. That means here somewhere. Okay. So this is called data cleaning technique. Okay. We have to find out the missing figure. Okay. So this is called data cleaning. Okay. When we clean the data or we don't have the missing. Okay. So we plug in this data here. Okay. As I want to know what happens at 15.5. Okay, and now you can see this another example. So which is predictive one. Okay, so here we know this data, so we'll understand what is the behavior of this attributes X and Y. And once we understand the behavior of this attributes X and Y, and then we'll try to predict. So what happens here? Okay, so for example, this is the sales we can have, or this is the purchase by a family in the 7th month, 8th month, 9th month, and 10th month, 11th month, and 12th month, and 13th month from the opening of one certain shop. What will be the family will purchase in the 15th month? Okay, so you can see it happens that it increases somewhere, decreases somewhere, again it increases, again it decreases. So we have to predict now what will happen. Okay, and that's why this is the predictive model that we are going to construct for this data. Okay, using the tool regression. Okay, and we are trying to construct in both the ways. So x on y and y on x. Okay, so let us try to solve this. And again, we have to find out how much confidence we have in this model. So that is going to be R. Okay, so we go with the solution. Okay, so what we have here, so you can see, let the line of regression of y on x be given as, so what we know, y minus y bar is equal to byx, x minus x bar, that is equation 1. So where we will be having here byx is equal to summation xi minus x bar yi minus y bar on, we are finding byx, so it is summation xi minus x bar square. This is equation 2. Okay, and what is terms are going to be x bar and y bar here, and x bar is equal to summation xi on n, y bar is equal to summation yi on n is equal to number of observations. So how many observations here we have? You can see. So we have 7 observations again. So here n is equal to 7. We have. Okay. And now the line of regression of x on y is given as, so what we have, x minus x bar is equal to bxy. Please be careful for this bxy and byx. Okay, because that is going to decide which is the line. Okay, so bxy, y minus y bar. So this equation 3. Okay, and what is bxy is equation 3, where bxy is equal to summation xi minus x bar yi minus y bar. This term is common. Okay, so where the change is? The change is in the denominator. So here you'll be having yi minus y bar bracket square. So this equation 4. Now you can see all that required we have considered. Okay, so we have the line of regression of y on x, we have the regression coefficient, then we have the line of regression of x on y, and we have the regression coefficient. Okay, and now we have to consider the table. So now consider the following. Okay, so let us consider the table. So what we require in this table is, as we know, so here this x is given, y is given, then we want xi minus x bar, we want yi minus y bar, then we want a product of this, so xi minus x bar, yi minus y bar, and we want the square of this, so xi minus x bar square, and we want yi minus y bar square. Okay. And the most important thing that we want the summation of this columns. Okay, so we are not interested in this sum, but we are always interested in these sorts. So these are the columns of our interest. So we have to find, and then what we can say. So from above table, we have, so what we'll be having here, we want to calculate x bar. So summation xi on n, and here n is again 7. So we have to calculate summation y, sorry, we have to calculate y bar, and here summation yi on n. So again n we are having 7. So I want you to write down the observations and calculate what this summation x and summation y is. So give me the summation x and summation y. So give me the summation x, what you get, and summation y, you get. $70 and 113. That's great. So you got 70 and 113. Good. Okay. So you got this summation to be 70 and this is going to be 113. So you got here 70 and 113. So this is 70. Okay. And this term is 113. So this is going to be, this average is going to be 10. Okay. And this average is going to be 16.142. Okay, so now once you got this average to be 10 and this average to be 16.142, now you have to calculate this two columns first and then calculate these three columns. So now we are interested in these three sums. So please calculate the remaining table. So I hope you will calculate the remaining table now. So I hope you are calculating with me. So what are the values you are getting? Are you getting the values? Great. Akshal got this values. 19, x square is 28, and then summation of y square is 26.8572. Okay, that's great. So good, you got xy. What about the x square, capital small x square and small y square? Okay, how many of you got only partial got x small x square and small y square? And what about others? Yeah, Anushka got, Rudransh also got. Okay, good. Ashik also got. Anushka got 28 and 32. Anushka, you have to check your calculations. Okay, so let us see. Check your calculations with my calculations. Okay, so please check your table. Are you getting this one? If you are getting this one, it's good. This is what the calculations you must get. Okay, so I have considered the accuracy up to 4 digit. So we can have the accuracy up to 4 digits, and you got these values. So once you get this value, okay, what we have to do next? We have to find out the lines of regression. Okay, and after the lines of regression, we have to find the R. So first we'll try to find what is the line of regression of y on x. So y on x means first we have to find out the regression coefficient. Okay, so what we can say is from equation 2. Okay, we have what will be from equation 2. So what is equation 2? We have Byx is equal to summation xi minus x bar yi minus y bar upon what is the term you'll be having? Summation xi minus x bar bracket square. So here we can see we have got all these values. So this sum is going to be 19 and x square is going to be 28. So you can have this is 19 by 28. So please give me this value. What the value of this byx you are getting? So byx is 0.68 6786 6785. Okay, that's good. So what we have here, we are getting going to be 0.6785. Okay, and once I get this byx is equal to 0.6785. Okay, then I am able to find the line of regression of y on x, because this is the regression coefficient of y on x, and hence we can write the line of regression of y on x is, so what do you have? Y minus y bar, so 16.142 is equal to 0.6785 byx into x minus x bar. So that's what we have here. So this x bar is going to be 10. Okay, and hence we have, we'll solve this. Y minus 16.142 is equal to 0.6785 times x minus, you can have here 0.6785 times 10. So you got y is equal to 0.6785 times x minus point. We can make it okay. So as the multiple is 10, so we can easily make it. So it is going to be 6.785, and this will be plus 16.142. Okay. So we got here the line of regression of y on x is. And so what we can write here now, we can write from equation 1 we have. Okay, so the line of regression. Now we can get the line of regression. So please give me what is the constant you are getting. So this is 0.6785x. Okay, so this constant will be plus. So what is the constant that you are getting now? Yeah, what is the constant? Yep, it's going to be 9.357. Okay, so that's great. Okay, so we got here this is 9.3578. Okay, so this is the line of regression of y on x. Okay, and now what we have to do is we have to find the value of y at x is equal to 15. So this is, as I said, this is the predictive one now. Okay, so we have got the predictive model. Okay, so what happens as x is equal to 15. Okay, so let us try what happens at x is equal to 15. Okay, so at x is equal to 15. X is equal to 15. We have what we'll be having y is equal to 0.6785 into 15 plus 9.3578. So what is the value of y you are getting here? So what is the value? 19, yeah, 19.53, 53 or 45. Yeah, you have the same numbers, but you are getting all different. So it is 53 near about 53. Okay, so fine 53 again 45 and 53 you are getting. So okay, I'll consider the correct answer. So we'll accept it up to 2 digits, which is correct. Okay, so it's good. Okay, and here what we get here is going to be this is 19.53, which is correct up to 2 digits. Okay, so this is the value of y when we'll have x is equal to 15. Okay, so that's what we have. Now, what is remaining in this question? So we also have to find the value, the line of regression of x on y, and then we have to find out what is the value of this small r. Okay, so let us try to find what is the line of regression of x on y. So we can write from equation 4. Okay, so we have, see, once you are able to solve the 4, then only you will able to solve 3. So that's why we have to be careful. Okay, and then so what we get here, so it is x minus, sorry, we have b x y is equal to, so what is that? Summation xi minus x bar yi minus y bar, and upon summation you have yi minus y bar square. So this what we have here, you can see from the table, so it is 19 by 26.857. Okay, so what we get here, it's going to be 19 by 26.857. So give me this value, what you gain. Okay, so what is the value that you have got? 0.7074. That's correct. You got it. Very good. Okay, so you are getting it now. Great, great. Okay, so you got, is going to be 0.7074. So it is 0.7074. Okay, so that's what the value we got for the regression coefficient of x on y. And now once we get the regression coefficient, so we can write from equation 3. Okay, the line of regression of x on y is, so what you got, x minus 10, and here you got 0.7074, and here you have y minus 16.142. So x minus x bar is equal to b xy and into y minus y bar. Okay, so let us simplify this equation. So you got x minus 10 is going to be 0.7074, and y here minus, what do you have here, 0.7074, okay, into what do you have, 16.142. So we got here x is equal to 0.7074y minus 0.7074 times, here we have, this is 16.142 and plus this 10. Okay, so that's what you'll be having, and hence we can write the line of regression of x on y is, so you got x is equal to 0.7074. Now give me this value, whether it is going to be positive or it is going to be negative. So what is the value you got for the question? Minus please be careful for the calculations. All of you are getting three different values. Okay, so 41 is correct, but 88, 94, and then this is happening because of the accuracy that you are considering. So either you are considering less accurate values or you are considering more. Okay, so that's why I said when you want to consider the accuracy, consider at the most 4 digits. Okay, so do not abbreviate it to 2 digits because when you will get in 2 digits, your error will be more. If you consider the 4 decimal digits after the decimal place, then you will be getting the more accurate value, or that will be accepted. So please use the 4 decimal accuracy. Okay. So what you got after the 4 decimal accuracy? So 1.41 is the correct answer. Only 9488. That is the question, and the 74 is the question. Okay. So please consider this. So I'll write minus 1.41. Okay. So you need to consider this accuracy, and here you'll be having this will be y. Okay. So here the line of regression is minus 1.41. Okay. So this is the line of regression we have, and now the part remaining is to find the value of r. Okay. So what we have is we have r is equal to square root of it is dxy into byx. And moreover, you can observe that see the sign of bxy, it is positive, and then see the sign of byx, it's also positive. Okay, so both the regression coefficients are positive. Remember that either both the regression coefficients will be positive or both will be negative. And if you are getting one positive and one negative, then that are not the lines of regression. Okay, so then the equations given are not the lines of regression. So here we have this is going to be 0.68. What do you got here? So this is 6785 into 0.7074. Okay. So this is what we have. Now we calculate this value. Please calculate up to the 4 digits. Okay. And hence we got r is equal to. So calculate up to the 4 digit and give me the answer. What you will get? Okay. So definitely your answer will not be more than 1. Yeah. So good. Yep. Okay. So you got answer. That's going to be 6928. Okay. So you have the answer 6928. Okay. So that's great. You got the answer 0.6928. Okay, so this is the value is the coefficient of correlation between x and y. Okay, so this way we are able to get the coefficient of correlation between x and y. And now here, what is coefficient of correlation suggests that 69% we are sure that this is going to happen. Okay, so whatever we have calculated or whatever we have predicted, the chances of happening of that are 69%. Okay, so that's what we'll be having. Okay. Now, do you have any doubt in this question? Do you have any doubt in these questions or create the questions we have solved? Okay, that's great. You don't have any doubt. Good. Okay. Okay. So, thank you for joining this lecture.